In this video, we're going to be looking at more graphing quadratics. So nothing really new in this video other than just seeing the quadratics when they're in the two different forms of standard form and vertex form. So just to kind of remind us a little bit about what we already saw. So we saw that when we can have a graph of quadratic, we can see it in what's called our standard form, which is the ax squared plus bx plus c. Graphing revolves really around the vertex, right? So we know how to create that table of values if we need to. And so in standard form, we have to use our negative b over 2a, or opposite of b over 2a, to get the x value of our vertex. And then we can substitute that in or use our table function on our calculator to generate our table of values in graph. So I'm just going to do one of these two problems. If you want to do the extra one just to kind of see what it looks like, you're welcome to. But I'm just going to do one of them just so you don't have to see the same thing over and over and over. So let's say I'm going to do question number 2. And this one is again in standard form. So we see no parentheses, we have an x squared, an x, and the constant at the end of 16. And so the first thing we're going to do is use our axis of symmetry formula to find the x value of our vertex. So this is my A, B, and C. My B value is 12, so I'm doing the opposite of 12 over 2 times 2. When we go ahead and do 2 times 2, that's 4. So the opposite of 12 over 4, or negative 3. And so now when we create our table of values, and I'll switch colors here, we get negative 3 as our x value. And again, we can substitute those in if we like, or if we want to use the y equals function on our calculator and generate a table, again, that saves us a little bit of time. So we have 2x squared plus 12x plus 16. I'm going to find where my axis of symmetry is. That tells me where my table centers around. And it tells me negative 3 is going to be at negative 2. All right, so that's going to be my vertex. I'm now going to pick values above and below. So I got negative 2, I got negative 1, I got negative 4, I got negative 5. At negative 5, I see it's a 6. At negative 4, I see it's a 0. And we know we're in a good place because we're seeing it reflect. And now we're going to go ahead and graph it out. So our vertex is at negative 3, negative 2, which is right there. We have negative 4, 0. We have negative 2, 0. And then negative 1, 6. And negative 5, 6. If we go ahead and take these points, we're going to go ahead and graph them. And you can see this is a quadratic. The graph opens up. It is more narrow because of that 2 in front. And then our vertex, again, is at negative 3, negative 2 is our vertex. And if the question asks for our axis of symmetry, or that vertical line in the center, it was negative 3. So that's our line that would divide it in half. The next one we're going to look at, again, number 1 is there if you want to look at, try it, if you wanted to try it side by side, but you don't have to. I'm actually going to jump to question number 4. And question number 4, you can see, is not in standard form. This is one that's in vertex form. So vertex form, again, is the one that's a little nicer. That A in the standard form is the same as the A in the vertex form. So those kind of stay consistent. The nice thing about vertex form is we don't have to use negative b over 2a. We can just simply pull it out from the equation. So the subtractions part of the formula, so the opposite of positive 4 is negative 4, and our y value stays the same. So our vertex is negative 4, 2. If we go ahead and do our table of values, I'm going to pick values above and below. So I have -3, I have -2, I have -5, I have -6. And then we can go ahead and either substitute those values in to get the y values, or we can go ahead and use our calculator with the y equals in there. So I could type in -2. When you do that, make sure you're not hitting the subtraction sign, you're hitting the negative sign, and then x plus 4 quantity squared plus 2. And then when I do second and graph, we know we did it right if you see the vertex in your table of values, and you're going to get -6, 0, 2, and then it repeats. And then we're going to go ahead and just graph it out. So we have here, I'm going to graph the vertex first, but you don't have, you could go top to bottom if you like. And so we have -4, 2. We have 3, 0. We have -5, 0. And then we have here -2, 6, and -6, -6. And then we would go like that. And so this one isn't a coincidence that it opens downwards. And it's actually narrow because of that too. But again, same concept.